Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 1 and we're on question number 39. This question is pretty hard because you need to evaluate two integrals. Both of them are kind of tricky, and especially if you don't remember your inverse trigonometric arc antiderivatives. So if you do, then it's not so bad. The integral on the left is arc sine of x over a. But if you don't remember that, I'll show you how to figure that out. If you look at it, you got 1 over square root of a squared minus x squared. So you can draw a triangle that has a hypotenuse of a. One of the legs is x, and then the other leg is square root of a squared minus x squared. Call this angle theta. So then you can write some identities like sine of theta is equal to x over a, and cosine of theta is equal to the square root of a squared minus x squared over a. And then we can differentiate sine theta equals x over a, do implicit differentiation, to get cosine of theta times the derivative of theta. So cosine theta d theta is equal to the derivative of x over a, which is just dx over a. Now we can rewrite the integral as dx is going to be a times cosine theta times d theta. And then the denominator, square root of a squared minus x squared, that's just going to be a times cosine of theta. Okay, we used this here, and we used this here. And our limits of integration, well, when x is 0, then sine of theta, well, here I'll just write theta is equal to the arc sine of x over a. So when x is 0, well, arc sine of 0 is still 0. And when x is a, then arc sine of a over a, that's arc sine of 1. Which angle gives us a sine of 1? That's pi over 2. So we can write pi over 2 up here. Okay, now our a's cancel out, our cosine thetas cancel out, and we're just left with d theta. And we know that the integral of d theta is just theta. Let's erase this. And so the answer is theta evaluated from 0 to pi over 2. No, that's just pi over 2. And just remember, theta is arc sine of x over a. So, like I said before, it's arc sine of x over a. Okay, so the left side of our equal sign is going to be pi over 2. Now let's move on to the right side. This one's a little bit easier because you can just do a substitution. You see this, you've got an x squared down here and an x up here, so that should scream out substitution. So if we substitute u equals a squared minus x squared, then du is going to equal negative 2x dx, which is good because then the x's cancel out. So we can rewrite this integral as the integral. I'll fill in the limits a little bit later. X dx, well, dx is the same thing as du over negative 2x. So let's write that, du over negative 2x. And then the square root of a squared minus x squared, that's just the square root of u. And there's this x up here that was there before. So x's cancel out. Now, what are the limits going to be? When x is 0, then u is going to be a squared minus 0 squared. So that's just a squared. And when x is a, that's going to be, u is going to be a squared minus a squared, which is 0. Okay, so now let's evaluate this integral. Well, what's the antiderivative of u, 1 over square root of u? Well, that's like u to the negative 1/2. So we're going to add 1. That's going to give us u to the 1/2. And we have to divide by 1/2, which is the same thing as multiplying by 2. And then we have this negative 2 in the denominator, so that's going to cancel out. And we're left with negative u to the 1/2, which we have to evaluate from a squared to 0. Well, that's going to be, at 0 it's just 0. And then we're going to subtract the square root of a squared, which is just a, or the absolute value of a. But then we've got this negative here, so that's going to make this a positive. So that's just going to be a. Now, we're setting these two integrals equal to each other, so that means that a is equal to pi over 2, which is answer E.